Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of polar bonds. So what we have to remember is the concept of electronegativity. What is electronegativity? Well, in a covalent bond, you have two elements that share electrons. One element will tend to pull the electrons around it more than the other element. This will result in a greater electron density around the more electronegative element. Okay, what was electron density? Just in case you forgot, electron density has to do with the probability of finding an electron around a certain atom. Okay, so if it's got a higher electron density, there's a higher probability of finding electron around the element X, for instance, in this case. See how there's a bigger volume, three-dimensional volume, in which the color codes indicate the higher probability for the warmer colors. So this red would be the highest probability to have the electrons. And then as you cool off, it'd be less and less probability. And what happens here is you get a partial negative charge around the more electronegative atom and a partial positive charge around the less electronegative atom. Creates what's called a dipole. Okay, the way I remember the way the dipole looks is that the plus charge coincides with the plus part of the arrow, and then the arrowhead is the negative charge. Physicists, for some reason, use the exact opposite notation. Don't ask me why. But as chemists, you need to go from positive to negative. When you become a physicist, then you can deal with that later. All right, so we already discussed that there's a negative charge and then a partial positive charge for the other element that's not as electronegative, and it results in a dipole and a polar bond. Okay, so I've already drawn this for you. Element X is more electronegative than element Y, so that's why there's a bigger probability of finding this electron or these electrons in the bond around X than on Y. And because the electron spent less time around Y, that's why it gets a partial positive charge. So then there's the dipole moment. The dipole moment can be calculated quantitatively by looking at the partial charge times the distance between the two elements, and it's measured in debye. That's the SI unit for it is debye. All right, so polar molecules. Well, the main thing with polar molecules is that you get polar molecules whenever you have polar bonds and no symmetry. Or you could have lone pairs and no symmetry. Okay? So the steps are going to be to draw the Lewis structures, determine the VSEPR geometry, determine if there's symmetry. If there's symmetry, polar bonds or not, lone pairs or not, usually not a polar molecule. The symmetry will cancel out all the dipole moments. Whereas if there isn't symmetry in a polar bond, then it's usually a polar molecule. Okay? And polar bonds could be replaced with lone pairs either or. Okay? So if the lone pairs are present and they create an asymmetry of charge, so therefore there will be a dipole unless there's a symmetrically opposed set of lone pairs, and it will cancel the polarity, making it nonpolar. So check out the example videos for this and practice, practice, practice. Thank you and have a nice day.